Please turn your attention to the video screens for a message from AIAA's Aviation Forum Premier Sponsor, Lockheed Martin Corporation.
True innovation begins with a challenge, an unprecedented problem that's seemingly impossible to solve. A challenge like how to make aircraft that fly faster and farther with more capabilities and greater affordability. How to give our men and women in uniform the unique capabilities they need to carry out essential missions in challenging environments. How to protect communities from constantly evolving threats to their way of life. How to connect people on opposite sides of the globe, expand our knowledge of the universe, and even transport humans to the surface of Mars. Solving these challenges is essential to maintain human progress, economic prosperity, and global security. These imperatives are what give innovation a purpose that motivates some of the most talented people in the world to join Lockheed Martin. Extraordinary people, our key element of innovation, make the difference. Those who yearn to do impactful work that changes the way we live, the way we interact, and our understanding of the world around us. Our scientists and engineers are brave enough to push the boundaries of science and technology and dream of turning the impossible into possible. Their motivations may be personal, but they share a common mission: to solve complex challenges, advance scientific discovery, and deliver innovative solutions to help our customers keep people safe. The opportunity to tackle global challenges is what motivates our people. But the environment in which they innovate is what truly unleashes their ingenuity. From the very beginning, Lockheed Martin has been a place where ideas thrive, where innovators are unconstrained by conventional wisdom. Diversity is embraced as an asset, and the free exchange of ideas is the source of our collective strength. We don't know what challenges tomorrow will bring, but the people of Lockheed Martin stand ready to take them on. And the same environment of innovation that has been the lifeblood of our success for more than a century will continue to unleash the ingenuity of our people for generations to come.
Ladies and gentlemen, please welcome AIAA Executive Steering Committee member Ron Basir, Vice President of Engineering and Technology, Lockheed Martin Aeronautics.
Thank you. Good morning. Today is day 2 of Aviation 2018. Everything you need to know about today and every day from aviation is in your flight plan email. If you haven't read it, please do so. And be sure to download the Forum app using the QR codes and the URL found in your program that you were given when you signed in. The app will help you navigate all of our sessions and more. But at Aviation, it seems fitting to recognize AIAA's Design, Build, Fly competition, organizing committee, and any student participants in the audience. This year, there were 77 teams to participate in the fly-off. 16 of them were international. Clarkson University took home the first place prize. Second prize went to Virginia Tech, and the third prize went to Atlanta's own Georgia Tech. We invite you all to visit the hub in the exposition hall at 2:30 today. Watch the highlight video from this year's competition and meet some of the members of this organizing committee. Through DBF, tomorrow's engineers are learning how to work as a team to solve problems, seemingly impossible design challenges. That experience prepares them for a future that they will be collaborating every day with partners from across other companies throughout the industry and in some cases across the world to expand the envelope. Just as it is for many of you out in the audience this morning, building partnerships is a way of life at Lockheed Martin. I can think of no better way to embody this year's aviation theme, expanding the envelope, partnering for transformation, than to tell the story of the development of the F-35 Lightning II aircraft. While delivering this groundbreaking airplane was an incredible global collaborative effort over many years. Some of the team might tell you the effort was required to assemble today and tomorrow's track F-35, but it was really much more work. I would like to thank everyone involved with the Plenary Forum 360, the technical sessions that are helping us tell the story. And if you ever wondered about the evolution of the F-35, today is your lucky day. Somehow, if you've never found yourself wondering about the F-35 program, I hope I've piqued your interest. And now I'd like to introduce our plenary speaker who will help us kick off this conversation. Our next speaker is a true leader in the industry. He's the F-35 Vice President for Development and Production for delivery of both U.S. and international customers. I've known Jeff for many years, and in that time, I've learned he's an exceptional technical leader, a fantastic program manager, and he has an undying thirst for understanding both technical and programmatic details. Jeff has worked in the past as the chief engineer for the F-22 Raptor, the F-22 and F-16 program director and executive leader for our other fifth-gen fighter, and the one and only F-35. It was no surprise to me earlier this year when he took on a new challenge as Vice President of Advanced Development Program line of business, in other words, our Skunk Works organization. We're privileged to have him today here to talk about his experience with the F-35. I teased you a moment ago, but today you'll hear him speak about the evolution. Following his remarks, Juan Alonso will come to the stage and ask Jeff a few questions. So be sure to get your questions in using the conference IO link. And now please help me join Jeff Babion, Vice President and General Manager of our Advanced Development Program.
Thanks, Ron, and thanks to the AIAA. Special shout out for using that old picture of me. You can see I've got a little bit more gray hair than I did in that picture, and I promise none of it came from being on the F-35 program. It really is a privilege for me to be here today, and I think for you as well. An unprecedented 2 days where you're going to have an opportunity to go from concept development to the X-plane, the system design and development phase, all the way through production and now fielding of the world's most advanced fighter, the F-35. A special privilege that, as far as I can tell, AIAA has never done before, and I think after today, this will become their model going forward. As Ron mentioned, I'm now privileged to run the advanced development programs for Lockheed Martin, better known as the Skunk Works, an organization that is known for developing the most amazing airplanes in aviation history. You think about the U-2, the SR-71, the first real stealth aircraft, F-117, the F-22, and most recently the F-35. And the team today will talk a lot about how that ADP work, particularly on the lift fan, and then developing and flying the X-plane was instrumental to the winning of the F-35 program. Prior to this previous job, I was on the program for 5 years. I had the privilege to be both the deputy general manager and then the manager for 2 years. And I'll have to say, it's the most amazing job in the aerospace industry. Well, the Skunk Works job is pretty good too. But at the time, the program manager for the F-35 was the most amazing and rewarding experience I've had in my career. And I'll talk about 3 different things today, or I'll use 3 different adjectives that'll keep coming back. So when you think about F-35, what comes to mind to me is scale. It's probably the thing that changes it from any other program that industry or the government has attempted, is the scale of this program. So I'll try to give you an idea of how it compares. Unprecedented. Just the track today is unprecedented. But as the engineers and scientists go through the technologies that we developed to make this airplane work, the word unprecedented will come up on a regular basis. And lastly, for me, and I really think for our customers, transformational. The F-35 transforms the way our customers, the men and women around the world that own and operate the F-35, the way they fly, the way they fight, and the way they win. And we're just at the very beginning of what this airplane can do. And I know 20 years from now, when we're getting back together for the next AIAA on the next generation, whatever, we're going to look back and know that the F-35 has delivered on the commitment and the promise that we have made to our customers. So with that, why don't I take us back to the very beginning, or almost to the very beginning. Roll the video, please.
Strengths, weaknesses, and degrees of risk of the program, it is our conclusion, joined in by our colleagues from the United Kingdom, that the Lockheed Martin team
So I'd offer on that day, October 26, 2001, we had a lot of happy people. And I think we knew what we needed to do. But before we talk about exactly how we went about doing that, I thought it'd be important to give us context of why we were doing it. Because again, it's about this scale. Across the top, you can see the U.S. services as well as the international partners that came together with one mission. How do we develop the most advanced fighter in the world, enable us to talk across companies and countries, at the same time leveraging the purchasing power? I want to have the most lethal fighter in the world, but I want to be able to do it in the most affordable way. And so the 3 U.S. services, U.S. Air Force, U.S. Navy, and the U.S. Marine Corps, partnered with the 8 original partners. You can see those across the top there. And subsequently, we've added 3 foreign military sales customers, so think Israel, Japan, and Korea. They would pool their resources to develop not just 1, but 3 airplanes. And Art Sheridan will give you more details on how those contracts came together, but at the bottom line, they wanted to use the scale to be able to drive down the cost to acquire, drive down the cost to own. So let's talk a little bit about what they had from economies of scale. It's a little tough to see, but down at the bottom there, if we start on the right-hand side, the U.S. Air Force, initial program of record, 1,763. Many of you have seen that number. In essence, that's the number of F-16s that the U.S. Air Force has in the inventory and the F-35 would replace. Then you look at the U.S. Marine Corps and the U.S. Navy. Marine Corps just under about 420. That includes a combination of the B model and the C model. U.S. Navy about 240, 250 C models. Then you start to fill in the partners, so another 600, 700. And then the future foreign military sales beyond the 3 that you see there. Altogether, you're looking at a program of record or estimate over the next 30 to 35 years of nearly 4,000 airplanes. Again, a scale that had not been attempted. And you say, Jeff, look, F-16 built more than 4,000. F-15, F-18, all into the multiple thousands of airplanes. But what was different here, it started off as an international program and a joint service program from the very beginning. We've tried joint service programs before, F-111, others. I'd offer that they struggled to be successful. Many would say they didn't really end up being used by multiple services. And even F-16, while it came to sell thousands of airplanes internationally, it started off as a US-only platform. And only after development had finished on the first block of airplanes did we begin to sell those airplanes internationally. So it was an international coalition from the very beginning, bringing scale that was unprecedented. And if that wasn't hard enough, we're not going to do just one airplane. We're going to do 3. And so to the left-hand side there, we're talking about the A model. Actually, we got it reversed. A model's on the right there. So think about the U.S. Air Force, think about the Australian Air Force, and actually the most plentiful airplane that the program currently based on is the A model, the conventional takeoff and landing. Then we have the C model, specifically designed to land and take off on aircraft carriers, and primarily being purchased right now by the U.S. Navy. But in the middle is the most iconic. When I think of the F-35, and if I were to show a person of the F-35, they would recognize the B model. The short takeoff and vertical landing version of the airplane that replaces for the UK the Harrier. I'm sorry, for both the US and the UK replaces the Harrier. Combined, all 3 airplanes would replace at least 7 other airplanes in the inventory around the world, and it would bring capabilities that none of those 7 airplanes had. In fact, think things like the AWACS or others, where there are information nodes, or the ability to do command and control, something that none of those other airplanes could do. And at the core of this scale, then, provided production opportunity, production scale. So I want to take all 3 of these airplanes and build them on a single line, much like you would do in an automotive, whether it be Chevrolet or Ford. Coming down the line, you determine at any given time what airplane would come off that line, something that was unprecedented in the aircraft industry. Typically, lines are set up, they build one version of that airplane, and then they move to a next version, a derivative of that airplane, not a completely different airplane as these 3 are. But moving off to the right-hand side, the affordable global sustainment. So while they were built on the same line, they were intended to be as common as possible. So if you think about it, the F-15 and what it replaced, or the F-16 and the airplane it replaced, how many parts were common on those airplanes? No, it was a completely different design. And going forward, how many parts on the F-16 ended up being on the F-22, or any of the inventory? If you pick any Air Force in the world, what airplane do they have? If it's not exactly the same airplane, how many parts can go back and forth? I don't know of any. They might be a derivative of a radar or something, but part number to part number, they're not the same. On the F-35, we set out to make it as common as possible. And we'll talk a little bit about how common that is, but just think in general. The engine on the A model, exactly the same as the engine on the C model. The OFP that flies the airplane, exactly the same. It knows which airplane it's on. From a subsystem standpoint, and the things that you would normally take off and repair on an airplane, some 2/3 of those LRUs are common across all 3 variants. So why does that matter? Because when you buy a part for an A model, you're also buying a part for a C model. And what the partners in the US did is they pooled their funds and they buy the spare parts together. So rather than country A having their own spare parts and the Air Force having their own spare parts, they combine them. And it's simple to do the math. If I aggregate that purchase, I can dramatically reduce the cost to maintain because I'm buying more parts and I'm not carrying inventory that I don't need. So we have a global supply chain and we have a global resource for it. It's estimated that saves something around 30% for the cost to maintain the airplane. And why is that important? Again, it comes back to the scale. What their objective was to reduce the cost to not only own, but then to operate. And really where the scale comes into play and really why they're buying the airplane is around its operation and its ability to defend their countries. Never before have we had the coalition flying exactly the same airplane. So whether you're the Italians or the US or the Australians, whoever was in the fight, we're flying essentially the same airplane, the same mission systems. We communicate in an unprecedented way, providing situational awareness, airplane to airplane, flight to flight. Everyone knows what everyone else sees in the fight. And the team will talk a lot more later on this week on sensor fusion and how all this works. But again, a scale that had not been attempted before, and we intended to deliver as part of the F-35. I mean, how hard could this be, right? You've got 3 U.S. services, 8 international partners, 4 military sales in the future, so you have to design for that export. And we'd already just really had started wrapping up the F-22 at the time. Think back 2001, I was on the F-22 at the time. We were already well into test, into flight test, and just a few years later, we would go IOC with the F-22, the first 5th generation fighter. But I'm here to tell you in those 5 years I learned there's some big differences between the F-22 and the F-35. And apologies to my F-22 buddies that are in here, F-35, a tougher problem. His F-22 was optimized for air-to-air, and it had and has some fantastic air-to-ground capabilities. But F-35 was going to be multi-role. So not only did it have to be air superiority for those countries that needed it as their frontline fighter, but also had to have tremendous air-to-ground capabilities, which makes the challenge much, much more difficult. A look across the bottom there, the missions, and this is just a subset of the missions of which the F-35 was designed. Strategic attack, going in and taking out a surface-to-air missile site. Close air support, think A-10 replacement for the Air Force and the Marine Corps. How can we go ahead and support troops that are in contact with the enemy? The conventional suppress enemy and destroy enemy defenses, the SEAD mission, and of course the air-to-air mission. And when we look at the picture of the F-35, you don't see any external stores, much like you would see on a Raptor in the very first days, ensuring that you have the optimum LO performance. But unlike F-22, F-35 has designed a massive amount of external and internal stores. With a full load of fuel, the F-35 can carry more than 18,000 pounds of ordnance, and Doug and the team will talk to you specifically about what they are. More than 30 different weapons already planned, and many more in the future. So we're going to do 3 different airplanes, and we're going to do something that no one's ever done, is make a multi-role 5th generation airplane that not only has to be there the first day with its LO, but the next day after, a bomb truck going in there delivering heavy ordnance. And as with any fighter in this genre, we know that we can't build the stealth in later. So foundation and much things that we learned on F-117 and refined with F-22, we know we have to bury the fuel internally. Well, we buried a lot of fuel internally. 18,000 pounds of fuel in the A model. In comparison, that's almost as much as the F-22 carries, and it's a 2-engine airplane. Gives this airplane incredible range. The engine inlets. Technology development specifically for the F-35. The supersonic diverterless inlet. The team will show you in great deal the challenges that they face to develop that, but this provides you outstanding inlet performance as well as tremendous LO performance, ensuring you can hide the inlet and the engine face from an LO standpoint. And then the common aligning the edges and embedded apertures, and in fact, a tremendous amount of effort on how do we reduce the signature of the nozzle. We all know that is one of the areas that is toughest to hide on this kind of platform. And then bringing all the weapons internal, at least that first day. So 2 AIM-120s, 2,000-pound JDAMs, all carried internally. From an emission standpoint, this is where I think it separates now on the multi-role side, is the most powerful radar in any fighter, the Northrop Grumman APG-81. And the team will give you great details on this, but just think it can track hundreds of multiple targets simultaneously. It does synthetic aperture mapping, and it has a tremendous EA performance. On the data link side, we have the Multifunctional Advanced Data Link, or MADL. Really the key to allowing each F-35 to talk to each other and the F-35 to talk to other assets. Tremendous high bandwidth data link that prevents the enemy from seeing us and allows us to communicate. And Dr. Fry will show how that information gets into the cockpit, and so that every F-35 pilot knows what every other F-35 pilot sees from a target standpoint, as well as the aircraft state, who they're targeting, what kind of weapons they might use. Incredible situational awareness. Add to that the Lockheed Martin electro-optical targeting system. So forward-looking infrared, much think FLIR, it can detect aircraft on the horizon, as well as target not only stationary targets on the ground, but ground movers, laser designated for weapons delivery, battle damage assessment, a tremendous amount of capability. The team will talk a little bit more about that as well. One of the more exciting things, and again, probably see this as much as anything in the media, the Northrop Grumman distributed aperture system. So think 6 infrared cameras staring off to provide you 360-degree protection, primarily from missile launch detection, whether it be standard missiles, man-pad, gives you instant location of where that missile left so you can return fire immediately to that target. Additionally, gives the pilot, particularly in the B model, situational awareness around the ship and other airplanes. It turns night into day. An amazing capability. Think about replacing the NVGs that you would have on a normal airplane. This is now currently displayed inside the pilot's helmet. And the guys will talk to you about that amazing helmet-mounted display in their sections. Do I look at all like that goldfish? Because that's how it feels to be on the F-35 program. So we're going to do this amazing thing. We're going to take all these international partners. We're going to develop 3 airplanes in the period it would take to do 1. We're going to do missions that no other stealth fighter has ever done, and we're going to do it on the world stage in an unprecedented transparency. The 24-hour, 7 days a week, 365 news cycle. We all feel it. We're either part of it as part of the program, we're part of it in our social media. Nobody's ever done this before. I was at AIAA shortly after taking over the program, and a reporter from AvWeek comes up to me and says, Jeff, so what do you think about the recent failure on the C model static test? I'm like, well, I don't think it's going to be a problem. I don't know the details. That was code for I have no idea what you're talking about. But in today's media, someone had known, had been at the lab, they talked about a crack, and pretty soon they're asking their opinion about the crack, and all of a sudden they're writing articles about failures in the F-35 static test. And if you remember, that was a pretty sensitive point between the struggles that we had for the B model frames. It seemed to be every month or two, there was another article about more cracks in the F-35, air quotes. And so this is a unique opportunity in time. Certainly guys with my hair color started on their careers, there weren't cell phones. And even if you had a cell phone early on, it didn't have a camera. And now every cell phone has a camera, and everybody has instant information. I was hoping to try to figure out, on any given day, how many articles you think are written about the F-35. And think about this as international, right? Because you got everybody who's actually buying it, so the 3 U.S. services, the 8 partners, the 3 FMS, and then there's at least 2, 3, 4 other countries that are in the process of competing. And then you have the other countries who just want to use the fact that that country's buying the F-35 to bash that country. So you have a tremendous opportunity for some negative news on the F-35 every day. So I wasn't able to determine that, but I just went in and Googled F-35 cost. How many returns do you think I got? So just, and, it changes over time, but it was over 100 million hits. So I thought, okay, let's compare that. Let me type in G-O-D, God, right? I figure that's the limit here. 900 million. All right, so the F-35 is at least 1/10 as popular as God. That's saying a lot. And it was really cost. It's about the cost. But again, while this, I make a joke about the transparency, it actually has been beneficial in some way because you can't claim we're hiding anything. We're not that good. Everything that goes on, whether it be in negotiations with our customer or technical challenges, we've been very open and transparent about what's going on. I think that's the hallmark of the program, is how everything is known, so there's not going to be any huge surprises. So this is the audience participation part. I want you to raise your hand and just say, what one thing, when you think about maybe the news, an F-35, you've heard in the past? Just say, hey, technology or cost or something like that. Somebody raise their hand. Want a suggestion? Come on. All right, just yell it out. Cost. Schedule. So he said software, and you could probably say software schedule. Oh, wait, and that goes back to overrun. Less capable is the F-16. Well, as you can see, there is no shortages of challenges. And certainly if I think about what the first thing that comes to mind, unfortunately to many for F-35, is the cost or is the schedule delay. So I'll talk a little bit about those entities. So awarded the contract October 26, 2001. And within a couple years, recognize that some of the assumptions we made about how we're going to put the airplane together, the manufacturing technology, think small number, large bolts, large tension joints, wasn't going to work out, that the weight of the airplane was starting to decrease. We had some technical challenges with other parts of the program, and we recognized that we really essentially had to redesign primarily the B model to reduce its weight, and Art and the others will talk specifically about that, but also the way we're going to build all the other airplanes. And so that caused us to then re-baseline the program, extend the program, and add some additional cost. But before we talk specifically about how much, again, I think it's important to talk about the scale of F-35. As I learned when I got into F-35, it's like you add a zero to after every calculation that you're doing because of the program size. So think about the development program and its initial production buy, approximately $325 billion. If you take a look and you say, well, the F-35 is a country, and I go look at the gross domestic product of the top 200 countries in the world, F-35 would be 50th on the list. So we're bigger than 150 countries. That's a lot. And hence, you're going to get a lot of oversight. You're going to get a lot of help. And it's absolutely reasonable given the amount of money that we're dealing with. While we're only one of several airplanes in the U.S. inventory, internationally, we are their frontline fighter. And so it's important that we understand how this affects their economy, and they're counting on us delivering. So it's reasonable that there would be questions about the cost. So about 2005, we extended the program about another 18 months, added about $2 billion to the program, but the real watershed event was the Nunn-McCurdy. 2010, our customer was notified Congress that the program would break the Nunn-McCurdy or have a Nunn-McCurdy breach. So what does that mean? It means the estimated URF, or the recurring cost of the airplane, is going to exceed by more than 25%, or the program in general is going to overrun by more than 50%. So all stop on the program. We're going to re-baseline this, make sure that we have sufficient testing and budget to finish the program. And a tribute to the men and women that went through that very, very tough time on the program. But what they came out with was an incredibly comprehensive program, both risk management and the cost it would take to complete the program. And I could say that at that time that we added about $6 billion and estimated the SDD program would move from 2012 into 2017. We stand here today and we're within a few months of actually achieving that baseline on a schedule standpoint and just several % higher on cost. So it was tough, but as we'll talk about later, we got there. The other aspect of cost that you hear a lot about is the sustainment cost, the cost to own. And we don't have anything in the briefings that's coming up that directly addresses the cost to sustain, but it's something that I think from a lessons learned standpoint, and those of you out there who are going to design the next generation of airplanes, is we need to increase the focus. In an unprecedented way, Congress is looking at the cost to own the F-35 over its entire life cycle, every building that's built, every job that's added in the U.S. government for 56 years. Do you think we thought about the total cost to own the F-16 when it started almost 50 years ago? Or the C-5 and the U-2 60 years ago? No. But that's the new metric. And so what are we doing as an industry to ensure we reduce the cost to own? And we know the cost to own is established when we designed the airplane in the very beginning. So I think as we go forward to whatever the next airplane is, we need to pay close attention to how do we maintain that airplane, because it's extremely important to our customer to reduce that cost. And I think we have a great opportunity in the F-35 program, probably something that we've never had before. And also, much of that cost was in the past. I want to talk today about some of the unprecedented successes. So, after nearly 10 years, the Joint Program Office, the Lockheed Martin industry team, Northrop Grumman, and BAE have been able to declare completion of the F-35 SDD flight test program. What an amazing accomplishment. Talk a little bit more about that soon. Several of our customers have already gone operational with the airplane, and we have told from the U.S. to the Israelis to the U.S. military that the Israelis have already used their F-35 in combat, and from what they tell us, it's doing very, very well. And just about 2 weeks ago, delivering the 300th F-35 to our Air Force customer, aircraft 151. So let's talk a little bit about that SDD program. As J.D. McFarland would say, is the most comprehensive flight test program ever attempted. And I completely agree. And it wasn't an individual effort, it was a team sport. Not only was it led by Lockheed and its industry partners, Northrop Grumman and BAE, but also integrated our government customer into what we call the Combined Test Fleet. One team, one test force. Encompassed all three variants, 9,200 test points, or test flights, over 65,000 test points. Again, unprecedented level of detail and scrutiny on this weapon system, not only from the air vehicle performance, but also avionics. I talked a lot about the weapons certification, so 183 different separations, 46 accuracy tests for score, making sure that those weapons left and hit their intended targets. And those mission sets, the effectiveness test, think about the graduation ceremony for the entire weapon system. On the production side, 300 F-35s. You may recall we only built 185 F-22s. On our way to more than doubling that on F-35. I think I was told that here in Marietta, the forward fuselage for the 350th airplane has begun, the wing for the 350th airplane as well. Again, I talked about the 3 U.S. services and now 11 international customers. The picture there is of our Fort Worth facility, over a mile long, end-to-end stacked with F-35s. Don's going to talk to you in great detail on how we put these airplanes together. But Marietta, or Fort Worth, is not the only final assembly and checkout. We actually build the airplane in 2 other locations around the world. The Italians build their own airplanes, or they do their final assembly and checkout, as well as building the airplanes for the Netherlands. And Japan has its own facility in Nagoya, building the airplanes that they have bought. And I think in the future there's opportunity for them to build potentially other customers as well. And while it's an international program from the customer side, it's an international program from the supply side as well. 1,600 suppliers, more than 100 of those international. So not only did the Italians buy into the F-35 program so they could have F-35s, their industry also got the opportunity to make parts for the F-35. In fact, 1/3 of the wings that will be consumed by the entire F-35 program, regardless of customer, are actually made in that facility in Italy. The number of jobs, we keep track of the kind of first and second tier jobs, almost 200,000 in the US alone. If you look at it from a cost standpoint, the very first airplanes cost about $240 million each. And over the last 9 lots, we're delivering the Lot 10 airplanes right now, we've driven that cost down more than 60%. An A model costs about $94 million. And if we continue with the technology advancement and cost reduction efforts that Eric Branian and his supply team are doing, we see a vision that we'll have an $80 million F-35 by 2020. A price that will be lower than any other fighter in the world and will have capability of no other fighter in the world. And we're doing this all while we're ramping. In 2011, we only delivered 9 airplanes. In 2015, we were up to 45 in a year. This year, we're on track to deliver more than 90 airplanes. And then just 2 years from now, more than 150. A tripling of the number of airplanes in a 3-year period. So you're seeing tremendous expansion of the facility and our supply chain around the world. But all this doesn't matter if the customer doesn't like the product that we're providing them. So I want to spend just a little bit on their perspective. In the middle of June, 4 F-35Bs, the Royal Air Force, landed in Marham to begin the stand-up of their initial operational capability at the end of this year. And at the time, the Defense Secretary, Gavin Williamson, said this: with a game-changing ability to collect crucial intelligence, fight wars, and tackle terrorism, these are the most advanced jets in British history. Pretty strong statement coming from the customer. But they're not the only one. Let's hear a little bit from the rest of the customer set. Roll the video. As I mentioned, the U.S. Marine Corps went IOC with the airplane, their B model, in 2015. U.S. Air Force followed about a year later. And then by the end of 2017, the Israelis declared IOC in December of 2017. Up this year, we have the UK in the fall, the Italians quickly thereafter, and then the US Navy right after that, probably in early to mid 2019. So you can see the customer set is just expanding exponentially in the use of this airplane. As excited as we are to be finished with SDD and ramping up the production and fielding the airplanes, it's important we think about what comes beyond SDD. And so this talented group of engineers and scientists are moving quickly into what we call follow-on modernization. So while the requirements that the F-35 was designed and built for are probably now close to 20 years old, the world hasn't stopped developing. And so we need to make sure that the F-35, for all the nations, continues to advance its technology. So over the next 10 years, working with the Joint Program Office, we've developed approximately 60 new capabilities that will be brought onto the airplane between combinations of software and hardware upgrades. We're tracking to a new distributed aperture system that increases the resolution some 5 times while reducing that cost that we talked about. We're putting auto GCAS, the ability for the airplane to take control and avoid running into the ground, something that we've implemented on F-16, and now I think we've saved at least 5 or 6 pilots just in the last year or two since that capability went online. We'll have that same thing shortly on F-35. Thinking beyond, say, 10 years, and a lot of the work that I'm doing now in the Skunk Works is what do we do not 10 years from now, but 15 to 20 years from now. And while we have a significant number of weapons to integrate over the next 10 years as part of the partners, we also have a whole new set of things, different kinds of weapons that currently aren't in our inventory. Engine technology, working both with GE and Pratt & Whitney on what is the next generation engine that goes in the F-35 that can give us significant reduction in specific fuel consumption, increase thrust, all those things that every fighter pilot wants. And an area that I find very, very fascinating is work that we're doing in artificial intelligence and machine learning. Both from an application standpoint, how does machine learning enable us to detect targets faster or reduce the time it takes the pilot to make a decision? Think about the future cockpit. Right now, the F-35 has the helmet-mounted display already getting to a cognitive assistant, putting that information in front of the pilot real time for him to make a decision. Can we expand that to where maybe there are no windows? The only vision that the pilot sees out of the aircraft is one that's completely augmented, where he can see in spectrums that the human eye can't see in, and it becomes virtually natural. How does that artificial intelligence help him or her make better decisions? It's an exciting landscape that we're just barely starting to touch, working actually with Google in some of these areas to try to find opportunities going forward. So in closing, I've had an opportunity to look at the past. How did we get here? Why did we develop the F-35? And I'd offer that hinge point was around scale and doing something that was unprecedented. And then the current, today, what are we doing? What does it look like in the factory? What are the men and women that are operating our airplanes saying about it? And then the future, which is exciting, is where do we take this amazing platform? But hopefully, what you got out of this is the amazing capability that the F-35 has and how excited we are to share that technology and discuss it. The men and women who actually developed this technology finally get to sit down and give you A to Z on how they did this. I'm looking forward to our time here over the rest part of the conference. And with that, I'd like to open it up for some questions. Thank you.
Thank you, Jeff.
Great. Thank you, Juan.
What an amazing technical accomplishment by the Lockheed Martin team. and I would say all of the partners, both domestic and international. So we have a number of questions, and I'll encourage the audience to continue to ask those questions and actually vote for the questions that you'd like to hear so we can see them here in the laptop. But let's start with a fun one. There seems to be a lot of interest in comparing the F-35 to other tactical multi-role aircraft that are either coming online or exist, like the Su-57 or the Rafale. So what would you say about that?
Well, what can I tell you? Well, I think what we know is that there's been a significant acceleration in the technology in both the Russian fighters as well as the Chinese fighters. And it's clear that by the way they're pursuing, when you look at the technologies that they're pursuing, they're chasing us. They're trying to get to 5th gen. And so if there was any doubt on whether we need a 5th gen fighter, all you got to look at is at the Russians and the Chinese, because they are attempting to become it. I don't think it's any coincidence that many of the, if you look at those airplanes and you hold your head just right, they look something like an F-22 or an F-35. And so as a nation, I think it's incredibly important that we recognize that while we may have a lead, it is a lead that can vanish quickly. And I was recently looking at some of the testimony by the Vice Chief as well as ex-Secretary Work about the third offset. And the concern is that these leads are tenuous and that we need to act like we're behind to make sure we stay in the lead.
Yeah, well, that's a great answer. There's a lot of interest in knowing whether the F-35 is going to be the last manned fighter. What does Lockheed Martin think about that?
Yeah, I think absolutely no. What you're going to see is, I think, more manned-unmanned teaming. I think there's tremendous value in not being a pilot, but knowing a lot of them, is having that man in the loop. And no matter how well we advance artificial intelligence and the ability to make decisions, when it comes to doing some of the things that we have to do with these weapon systems, you want the man in the loop. And so actually, Lockheed Martin is looking at that manned-unmanned pairing. So how do you take a manned asset, put unmanned assets in that same area, and let the manned asset manage those unmanned? It's very intriguing. It provides a completely different dynamic for your adversary and provides tremendous leverage for the warfighter. So I think that's where we're going. It's like, we used to think that you would never put a gun on a fighter. Why do you need a gun on a 5th generation airplane? Well, both F-22 and F-35 have a gun, and I think the Air Force has told us we're going to have a gun. So it's a lot about the customer as well, but I think you're going to see manned flight for a long time.
Yeah. There seems to be a lot of interest on the topic that these are complex programs, hardware, software, multiple roles, different versions, et cetera, and that we need to learn how to design these types of systems as we go forward. So what are the key lessons learned that you would apply to some of the programs that you'll be leading in ADP that you learned from the F-35 program?
Yeah, I think planning for that upgrade. As we look into the efforts that we're doing with modernization, what we see is there's certainly constraints on the hardware, the architecture that we established. And while there was clear requirements when we developed F-35 to add capability beyond the SDD program, I think we underestimate what that is going to take. It was an interesting conversation. We met with Eric Schmidt, who runs Alphabet, used to be the Google CEO. And we were talking about how we had sized the computers and the excess capacity so that we had this growth capability. And he said, you guys got it all wrong. You're only adding about 1/10 of what you should. And as we got into that dialogue, it was all about the data. And you see what they're doing with their Google Maps and all the information that they have in these server farms. They keep everything that they produce from a data standpoint. Because what he offered, if you don't over-spec the hardware, you'll never be there with the headroom for the software that you want to run. And no matter how much you think you have, you don't have enough. And so I think going forward, especially now with the type of aircraft that we have are really flying computers, we've got to make sure that we install that added capability and really commoditize that. Sometimes we have spent in the past tens of millions, hundreds of millions of dollars developing computers that now you could develop much cheaper. So philosophically, do you now design those to be almost throwaway? Something that we have to look at. If you're going to get to very low-cost unmanned vehicles, even very low-cost manned vehicles, you have to address those hardware costs and the speed at which you get there.
Sure. The top question I have to share with you, it's I think very relevant to what you were just discussing, and it's worded as follows. It says, with the rapid pace of today's technology development, which you were alluding to, is the multi-decade aircraft development model still relevant? Do we need to think about it in a different way such that you can upgrade to the system as it goes so it does stay ahead of the competition?
Yes, I would answer that this way. It's certainly our expectation from our customer that we accelerate the time. As you mentioned, F-22 was 20 plus years. F-35, we're sitting at 20 years now. We can't stand to take 20 years to do it again. But this is a combination of what industry can do and what our government counterpart as well. So this is where I think it's going to take significant teaming. We spend a significant amount of time and energy developing unique systems. Yeah. We need to be collaborating with our government counterpart on how do we take what's commercially available and change it, but minimize the change so we can rapidly replace that hardware. We talk about requirements. JD and his team flew 9,000 flights and 65,000 test points. That unto itself takes time. That took 10 years. So we have to be able to go forward with the expectation is that we will field with less actual test. Yeah. So simulation, virtualization is going to be important, that we sell off requirements to the design or a test, not an actual flight test. So yes, I think it's the future. The challenge is the how. You have test communities that want to oversee the testing and then do testing themselves. The F-35 is just now starting its initial operation and test and evaluation in August of this year. That's after 10 years of development testing. So I think it's a collaboration between the customers that are buying our products and the innovation of our engineers and technologists that enable us to provide higher confidence in the performance, but doing that testing in some kind of virtual environment.
And you started down the road with essentially a modular aircraft with many parts being shared. Is that concept of modularity going to have to be pushed to the limit so you could really replace and upgrade? Is that
absolutely? And I didn't spend time on it, but at the top of my last chart was OMS, Open Mission Systems. So think about non-proprietary open interfaces that allow us to bring in a new radar technology, a new DAS technology, a new EW system. All that can be done by providing the right architecture. And Lockheed Martin in advanced development programs, the Skunk Works, is kind of leading the edge on how to do that. So we've demonstrated upgrading a U-2 or an F-22 with new radios, new sensor platforms within days based on this open system. So I think that's foundational on going forward. Every airplane will have that going forward.
So since I have a laptop, I get to ask whatever question I want. So I have one that I have a particular interest in. And somebody asked, how did Lockheed manage the competing requirements of such different aircraft that have been sort of put under the same program name?
Yeah, it's a very relevant question, particularly when it comes to the cost side of things, because clearly the more common they would be, you would enable the reduction in costs. But each customer wanted their own version of the F-35. I think the B model kind of stands on its own because the short takeoff and vertical landing capability drives you to a significantly different configuration from an engine, flight controls, and the aircraft configuration. The A and the C model, more common, but yet unique, where you have to land on an aircraft carrier, you need to go slower. And so we tried to look at it from a value. It has to complete the missions, take off and land on an aircraft carrier, short takeoff, vertical landing, conventional operations, Mach 1.79 Gs, but then try to make it as common as possible, because that's where that cost savings was going to come. And so I would say we did a good job of balancing, but it was always a give and take. Don Kiner will talk a lot about how we made sure that we could build all 3 variants on the same line without making it seem like it was a difference. So with relatively small changes, any one of the tools can build any one of the variants. And it's a huge testament, I think, to the ingenuity of our manufacturing engineers as well as the engineers on the performance side that was able to make that balance. And I think for all intents and purposes, talking to our customer, we've struck a good balance.
So we're at the 1 minute mark, and I'm going to ask you one last question, and that is, if you had to do this program all over again, what things would you do differently?
Wow, that's dangerous.
Yes.
I would offer, if it would ended up with a different program, I wouldn't have changed it. I mean, Juan, I'm serious. I can't tell you how proud we are of what we have done as Lockheed Martin, as our industry partners, Northrop Grumman and BAE, our government partners on this program. Incredible amount of pride in achieving what we have. Has it been hard? Absolutely. But to change it and have it change where we're at, where we're going, what this airplane can do, what this airplane will mean to our customers, I can't offer that I would change anything significantly. Well, it sounds like a cop-out, but I actually believe that.
I have to say, it does boggle the mind how you guys were able to put all this together. So thank you so much for the insightful keynote and for your candid answers to these questions. Let me make a few announcements before we wrap up the session. So the hub opens today in the exhibition hall. So it's the first time that we've had this dedicated space for networking and collaboration at aviation. So we would like you to check it out. At 1 p.m. today, you'll have a chance to watch a live interview with ACubed CEO, Rodin Lasov, who was here in the plenary panel yesterday morning. Later in the afternoon, more exciting even, you can participate in a paper airplane contest that will give you a full complimentary conference registration for the next Aviation Forum next year. So yes, you heard that right. AIAA is bringing down the house there. So tonight at 6:30 p.m. in the exposition hall is the opening. You need tickets to attend. Take this opportunity to make new contacts, to connect with all colleagues and friends, but also take the opportunity to enjoy the fact that local musician Brandon Crocker will be performing. We'll be running several social media contests throughout the forum. Look for your tweets and Instagrams in the displays that are all throughout the conference. All you have to do is just use the hashtag AIAA Aviation in order to enter. And we have lots of cool prizes, including gift cards, Women of NASA Lego set, and other things that would actually be given to the person with the highest total number of tweets that are relevant to the forum. That's the legals. Also, be sure to download the forum app. I've been using it myself quite a bit this conference. It's improved tremendously. It allows you to manage your schedule. It allows you to navigate the forum and to share your experiences. And to download it, as was said by Ron at the beginning of the session, just go to the QR code or the URL that's in the program. And with that, I would like to thank Jeff Babione again and wish you a great day, and thank you for being here at Aviation 2018. Right. Thank you so much.
You're welcome.
Jeff.
Thank you. Thanks, John.